Some of you may have had some experience in coding using C++. Quite a number of you have not. But then again, C++ is not a very difficult subject to master. And in fact, back in those days, those high school students who are taking computer science, they have studied C++ before. So having said that, it sure is not that difficult to study C++. Yeah, it's slightly confusing for beginners, but then again, it's not that difficult to master. So last week we've covered a bit about the structure of a C++ program. And this week we are going to have a look at the sequence structure of C++ program. These are the lesson outcomes that we try to accomplish towards the end of this class. Understand the basic program components. Understand the standard data type. Now, this is important, yeah? We've seen integer, float, string, haven't we? We have seen integer, float, string. We have char as well. So today, we'll try to have a look at all of these: integer, float, double, char, char with a square bracket, and string. Define and use identifier, variable, constant, and statement. Use the input and output statement, formatted output, and use the predefined functions cin.getLine, gets. Mathematical operators, we have plus, minus, asterisk, /, and percentage. Increment and decrement, the operators, good programming practices. Now, these are part of this. Now, this is the basic program components. A C++ program has the following form. All right. The first thing that we want to introduce is the line comment here. This is the line comment, meaning to say a line comment can only accommodate for one line. This can only accommodate for one line. It starts with /, double /. This, on the other hand, is a block comment. A block comment can accommodate multiple lines. So everything within comment will be neglected by the compiler. They will not be compiled together. Why need for comments? For example, we want to, in this case, we want to comment. We want to make sure that we know where the location is. We want to describe something. Or sometimes, even when we do the coding, we want to make sure that the code is not executed because we're still testing it. But we do not want to delete the line. So we can use either line comment or block comment. Yeah? Next point to introduce is the preprocessor or the library. Anything that you include. Anything that you include. Why the library? Because we want to use the functions inside the library. For example, IOStream carries cin and cout. Yeah, IOStream. Generally, it carries cin, cout. So this is why we need to include the library. Otherwise, we cannot use cin and cout. There are two styles of coding. One is like this. So we have integer main, we have bracket, we have curly bracket at the bottom. Notice. Well, my style of coding, I prefer integer, main, bracket. I start from here, curly bracket, and here, curly bracket. They're both correct. It's a matter of preference. Yeah? Most students who studied with me tend to code like this. Most students who studied with some other lecturers tend to code like this. But never mind, they are both correct. It's a matter of preference. These are introductory comments. The comments are not executed by the compiler and they are used only to allow the readability of the program. Types are two types of comment. One is a line comment. The other is a block comment. Notice block comment can accommodate multiple lines, whereas line comment can only cater a single line. All right, notice 2 lines, you have to use block comment. Block comment start with / asterisk, ends with asterisk /. Whereas line comment uses double /. This is common. Yeah, when you code, you are likely going to use this anyway. So we have got quite a lot to cover today because we will not have any class tomorrow, won't we?
Yes.
Yeah? You won't have any class tomorrow. This is why we have to finish this today. So that was comment. Now we're coming into the preprocessor. This is called the preprocessor. We have include iostream.h. Now notice about the h. Yeah, notice about the h. By default, we have to include the h. But some compilers, for any known libraries, we do not need to include .h. Math, for example, we must include the h. iostream, in our case, we do not need to put the h. But by default, you have to include the .h. Okay? iostream, as I mentioned earlier, allows for cin, for example, cout. If you want to use power, yeah, raised to the power of, you have to use math.h. So you have include iostream.h, include math.h. conio is required if you want to use get.ch, get character. Sometimes when you run a program won't stop. But then again, here in our case, this is not mandatory anymore. Why? Because the program, when it stops, it will wait for a character by default, isn't it? Yeah? When we run our program, it will wait for a character before it terminates. Is it not correct?
Right.
Yeah, correct. You have to press any key, then only the program terminates. So conio is not that useful for us. Now, we've covered about the commands. We've covered about the preprocessor. Move along into main. Move along into main. The word main. Hold on. Hold on. Sorry, class. My nephew just left. Right. So where were we? We were integer main. Yeah. We're coming into the main program. We have comments. We've covered about preprocessor. Now we come into the main. Main is the, as the name says, yeah, main. The main of the program. Without main, the program will not be able to execute. Now, main itself is a function. Main itself is a function. When it is a function, we have what we call this is return type. Yeah, return type. We have bracket, the parentheses. This is for if you were to put any parameters. And the word main, which must be typed in lowercase letters, is the name of the function. Yeah, must be in lowercase. A function is simply a block of code that performs a task. Void main is referred to as a function header because it marks the beginning of a function. Every C++ program has a function called main. Now, when we say void here is a return type, what is void? Void will not return anything. But void main, sometimes, void main is not the standard. Sometimes the compiler will complain if you were to use void main. Instead, you have to use the standard one, which is integer. Yeah, for a function with integer that return type, that's why we return not. When we return not, meaning to say the program runs okay. If we didn't get to return not, then the program is not working. It will return some other value. Understand? Hi, class? Are you here?
Yes, sir.
Yes.
So, right. Normally inside main, we will put variables. What is a variable? It is an identifier that refers to memory location, which can hold values. Variable can only store one value at a time. Thus, the content of variable may change during the program execution. Before it is used, it must be declared with its data type. Now, the keyword here is the data type. For example, we'll have a look at it in a bit. So this is inside RAM. What is RAM? RAM is random access memory. Yeah, random access memory that resides in the computer. The purpose of RAM is to store the values so that data can be accessed more quickly. Now, rules for naming a variable. So, what's the purpose of variable then? Do you use variable in your coding? Do you use variable in your coding?
Yes.
Yes, you must use variable. And how do you name a variable? The first character must be an alphabet or underscore. You cannot start your variable name with a number. you must start with alphabet or underscore. Can only consist of letters, digits, and underscore. You cannot use special characters. What are the special characters? For example, the hashtag. No, not possible. The question mark. Not possible. What was that? The alias. Not possible. And you cannot also use reserved words. What are reserved words? Words that are being used by C++. For example, can you use if as a variable name? It's not possible because if is meant for selection, isn't it? And there must be no blank space character in between. For example, customer name. Data type is string. Customer name. Is it possible? Is this possible?
No.
No.
No, not possible. Then how do you fix this?
Put the underscore.
You can put underscore in between. Or you can put them close together. Can you put hyphen?
No.
I believe you cannot put hyphen because that is also considered as a special character. And identifiers are case sensitive. Yeah, case sensitive, meaning to say integer age and integer age are different. They are not the same. Integer age is not the same as integer age. All right?
Why not?
Because this is case sensitive. This is lowercase a. This is uppercase a. So they are different. Okay? Do you understand why?
Not
Case
quite.
sensitive. Yeah, it's case sensitive. Now, these are some of the reserved word examples. We have integer, float, case, break, if, else, while, return, and all of these. They cannot be used as variables. Yeah, none of these can be used as variables. You have to choose a different name. Now let's have a look at the different data type. We are familiar with int, which refers to integer. Yeah, we are familiar with int, that refers to integer. Example, integer, no one, number 1 and number 2. So for every integer, allocation for that particular variable is 32-bit width, meaning to say the value can be between these. Long can cater for more numbers. Long can cater for more numbers because it contains 64-bit. Short, on the other hand, can contain less numbers because it only contains 16-bit. Now, next semester, you are going to study more into the relativity between bit size and numbers. Yeah, when you study csc159, you are going to go deeper into
Malah
this.
katuk bawa pintu tu. So indoor tu. Betul tak?
We
Atas sebelah
have
tinggi.
unsigned sum. When we have unsigned, by default, it is assigned. The values are signed. When the values are signed, we can cater for negative values. Yeah, we can cater for negative values. But when we specify unsigned, the values start from naught. Only positive values will be considered. Yeah, that's the difference between signed and unsigned. A char refers to a character. In this case, char name only can cater a single character. Char name square bracket n. N refers to the size or the length. Then we can assign the value like this. Notice the difference. Here we have single quote. Here we have double quote. And also take notice of the symbol used. This is the correct one. This is the correct one. This is the incorrect one. This is the incorrect one. This is the incorrect one. If you use, for example, Notepad, you're good to go because it uses the standard one. But if you are using Word, yeah, MS Word. If you are using any text editor, you'll be fine. But if you are using word processor, then you can be in big problem. Notice they are not the same, isn't it? They are not the same. Compare that to this. Okay. Are they the same?
No.
No, they are not.
No.
So we only, oh no, C++ only caters for the one at the bottom. Don't use the one on top. And one more thing, we have had students in the previous semesters, I can't remember which one, instead of doing the double quote, they put a single quote twice, such as this. No, hold on, I cannot do that here. You have to do it in here. You do it something like this. This is also incorrect. Yeah? You must use that double quote, not a single quote twice. A single quote is fine for as long as you use a single character. Okay? Any questions so far? Next, we're gonna go when we're dealing with the floating numbers. Yeah, the floating numbers. Float amount, for example. Yeah, a floating number can accommodate for the floating points. So in this case, we have 2 floating numbers. Double can cater for more. Yeah, this is on the precision, approximately 6-digit precision, approximately 12-digit precisions. So even the size is different. I don't mind whichever data type that you use. I personally prefer to use float, but if you were to use double, you can do that. And moving on, we also have Boolean. Have you heard of the term Boolean?
Yes, sir.
Yeah? So a Boolean can only cater for two values, either true or false. For example, if you were to write bool ans for answer equal true. Or you can also use something like this. Bool ans equal 1. They refer to the same thing, right? So true and 1, they are the same. False and not, they are the same. Either way is possible. And finally, we have void. Yeah, void. For example, void main. But generally, void is being used only for the return type, not for the what is it? For data type. Only for the function return type. It's valueless. It won't return anything. So we've covered quite a bit. Now we're going to go into string. A string data type, programmer defined type, supplied in standard library, sequence of zeros or more characters enclosed in double quotation marks. Null is a string with no characters, and each character has relative position in string. When it says it has relative position in string, meaning to say it has numbering from 0 to whatever the length of the string is. So the first position is not, and it will continue by adding one by one. Yeah. Now in this case, they are the same. Yeah, they are the same. Programmer defined sequence of zeros, number of characters in string. Examples: string name equal John. Notice they are double quote. Right. This is how you declare your variable. Declare your variable. Integer num. Integer num to integer sum. You can do multiple declaration, or you can do something like this in a single line. Yeah, in a single line. They are both okay. When you declare a variable, what the computer does is to allocate a certain memory location. For num1, num2, and sum. It will allocate memory location for this value. And sometimes there are already values inside here. So if you declare alone, it's a good practice that you initialize the values. Yeah, you initialize the value. What is initialization? We'll go into that in a bit. Once the variable is declared, it contains non-useful value, garbage. To make it useful, the variable must be given a value, either by assignment statement or initialization. The value serves as initial value to the variable. Variable can be initialized to any values as long as the value's data type matches the variable's data type. C++ has several assignment operators, and most commonly used assignment operator is this. the equal sign. Assignment operation using the equal sign has the general form identifier, which is the variable name, equal expression. Expression represent constant, variable, or more complex expression. For example, age equal 10. So 10 will go into age. Right? This is a simple assignment. Assign a value inside that. More examples. To assign a value for a numeric data type, you simply assign like that. Easy. This is very common. For a character, a single character, again, similar, only that now you have to include the single quote. You encapsulate your character in single quotes. To assign a value to an array of characters, right? This is even more interesting. You must use string copy. Yeah, you must use string copy. String copy, title, and what you put in there. You copy the whole string into title. But in order for you to use string copy in preprocessor, you must include a library for, what do you have to include? What do you have to include?
String.
String, there you go. Correct. String.h. To assign a value from an expression, that's how you do it. Total equal number 1 plus number 2 plus number 3, or total 2 plus 4 plus 6. Either way is correct. Any question? No. Any question?
No, sir.
No, sir.
No. Move along. A variable whose values does not change throughout the program execution, we call that constant. We call that constant because the value doesn't change. So the value is constant. We can declare that using two approaches. One is to declare constant float pi equal 3.142, for example here. Or we can also define in the preprocessor like that. This is an example of how you would declare a constant using constant keyword. Const float pi equal 3.142, and this is how you declare that using preprocessor. Define pi 3.142. Notice here, you have pow. That's why you have math.h. Okay? You have pow. Pow is in math.h library, so you must include math.h. Now, more explanation. That's what we've covered the last time. The iostream.h. Yeah, the iostream.h allows you to use cout. Cout is to send output to the screen. And you have seen how it functions. Have you not?
Yes.
Yes, you have. So anything inside the double quote will be sent to cout for output. The result of the calculation will be sent to cout for for the monitor to print. Similarly, if you're dealing with variable, they will do the same thing. Integer total equal 10. Total is, notice here, we concatenate the string with the variable. So it will display total is colon space 10 in this case. And we also have that and that. To display formatted output and predefined symbol, when you use \n, it will move on to the next line. When you have twice of \n, it will move down 2 times. Or if you prefer, you can also send ENDL to cout, which will do exactly the same thing. Although, again, how they work will be slightly different, but you will achieve the same thing. It will move on to the next line. So that was on the cout using IOStream. IOStream can also accommodate for cin. Cin is meant for input. Yeah, cin is meant for input. Now, besides cin is fine. But cin, for example, if you have name, and the name is Ali bin Ahmad, what will happen? In your opinion, what will happen? So what you get is Ali here will go into name. Bin and Ahmad will not have any place to go because they are separated by the space. So they are treated as a separate input. So what do? You can either use gets variable name, cin.getLine variable name length, or getLine cin string variable. The gets variable name and getLine cin string variable is from the standard io.h. So you have to include standard io.h. Otherwise, you can also make use of that string.h that you have included by using cin.getLine. All right? You can do that as well. cin.getLine will get for the whole string in a single line. Any question? This is an example again. cin.getLine is used to read the entire string of input from user as a string including the blank space and new line characters. To use string predefined function string.h header must be included in the program. And the syntax take the form cin.getLine variable length. For example, cin.getLine text 80 indicates that the text variable used to store the string of characters, and 80 is the maximum length the variable text can store. Any question?
No question.
No? Example of input statement. To input numeric data type, we do the usual thing. Integer num1, float num2, we can cin num1 and num2. No problem. It will accept, it will expect. And you can enter in a single line. You can enter in a single line, such as this, separated by, you guessed it, space. Yeah? Space. When you separate your input with space, this particular 10 will go into num1, and 5.5, the number after the space, will go into num2. Char letter symbol. Cn letter symbol A will go into letter. Hashtag will go into symbol. Char customer name 80. Gets customer name. Now this is using gets. Gets and get line here. Gets and get line must be invoked after you include. What do you have to include in order to use gets? Standard IO. .h. Whereas cin.getLine customer name 80 here is used with string.h. Okay. All right. We have seen this example. We have done this example. Have you not? Have we done this? Please enter your name. You are. Hello, you are. And you are not Fahardi. Remember?
Yes.
Yeah. Yes. This is how you want to use get line. The same thing. You see, the thing is, I would prefer if you stick with one instead. Yeah. Personally, I prefer if you stick with this one instead. It'll be easier to remember. Hey, we've come to the end of chapter 2. Part 1.
Part 1.
Part 1. We have the second part. Yeah, we have the second part that we will cover next week. So what do we do now?
Does it?
You don't know. I know. I know.
Sir,
Yeah.
function untuk return 0 tu apa? Return 0.
Come again?
The return 0.
What is the purpose of return 0?
Yeah.
The purpose of return 0, number 1. Hold on. Here you go. Number 1, because here we have integer as a return. Basically, main here will return a value of type integer. When we return 0, here, meaning to say the program is good to go. The program works just fine. It will execute everything up to get up to here and return 0. But suppose that the program returns some other value, we can tell that the program is not running perfectly. Yeah, the standard implementation of main is when you have to use integer as a return value. If we did not include any return value, it will return 0 by default. Even if you did not write this line, it will return 0 by default. When it returns 0, we know that the program executes fully right to the very end. Any other question?
Okay, thank you, sir.
Right. Now, I want you to try to perform coding. Remember the tutorial that we've done? Yeah? Go to classroom. Yeah, you go to classroom and you start to look at the tutorial and lab. But now, instead of working on that question per se, you merely want to write the program. For question number 3, by assuming retirement age for a government staff is 60 years old, you need to calculate the retirement year based on age and current year input by a user of your program. Can we spend like 10 minutes to work on this? Yeah?
Yes.
Now, run your def C++. based on what we've learned so far, how about if you try to answer, not try to answer, but to code your answer in C++?
Hey.
Within 10 minutes.
Pala
And
mana?
we'll come back and check on your progress after 10 minutes. All right? Yay!
Tengok mana soalan tu?
Classroom.
Classroom.
Go to classroom.
Tutorial lab.
Yes, that's the one. Question number 3. Work on that
Ush.
implementation using C++.
Ayo.
All right, so now is 3:21. We'll come back at 3:30. Yeah? Easy peasy. Where's the screen? Born year, age, retirement year, enter born year, and age to calculate retirement year. Input age, input born year. Retirement year equal born year plus age. See out retirement year. Okay, fair enough. Try to run, compile and run. Now go ahead. Now, hold on a second. What is it? Input age. What is age? When you say input age, you put in 60 earlier. What is age? No,
Umur.
yes. No. You see the program that you run earlier? Where's the program? Go down, select the program. No, select the program that you run. Select the program that you run. There you go. Input age 60. What is that? What is that? What does 60 represent? Your current age, is it?
Yes.
If that is your current age, now show your screen, yes. If that is your current age, you are 60 years old. How come you are born in 2003? Isn't it? So this is what we call problem solving. So you have not fully understood the question. Okay.
So actually, I do. I change it many times because I doesn't understand the question.
You see, the problem here is you do not understand the question. I'm not only saying to you, I'm also saying to general, yeah, to the whole class. More than likely, you do not understand the question. The question is like this. Now, show the screen. Show the screen. No, that one, the program that you run. The program that you run.
Yeah, wait.
Or run again. Run the program. You don't have to compile. You simply have to run. Yeah, you don't have to compile. Now, right. Age referring to what is your age? Year is what is the current year. Suppose that you are 50 years old. What is the retirement age? According to the question, what is the retirement age? I'm asking the whole class.
60.
60 is the retirement age. if you are 50 years old this year, yeah, if you are 50 years old this year, when will you retire?
Two thousand 31.
Come again?
2000.
2031.
How do you know it's 2031?
Because the year we retirement is 50 years old. This 10 year.
All right, Noshaza, how about if you stop presenting? Let's try to ask Aidil. Aidil, can you please show your screen? Show us
Yeah.
how do you calculate? Why or how did you come to 2031 as your retirement year?
But I can run, but I can show the picture.
Yes, we only want to see the formula. How did you come to 2031?
Let's say, see,
Now, right, you have to write. What is the formula? How did you know that it's 2031?
I guess.
How do you calculate? How did you calculate? Guys, this is problem solving. What we're doing now is problem solving. You know the answer. How do you explain your answer?
60.
How do you copy your answer?
60
Uh-huh.
minus by 18.
Uh-huh.
Okay, and then you get 42, and then 2021 plus 42, and then you get the retirement age.
So, in this case, look at the question. Assuming retirement age is 60 years old. That is the retirement age. You need to calculate the retirement year based on the age. So what do you need user to input? What do you need user to input?
60 minus current age.
No. What do you need user to input? What do you have to input to the system? What is expected out of the user?
Age.
The age. Yeah, the age. First, user need to insert the age. Because based on the age, then only it can calculate. Is there any other requirement for the system
Yes.
to calculate? Yes, what is it?
The current year.
The current year. There you go. Any other current year? Any other things that you require or that your program require in order to run?
No.
No. So you have, let's see. Now, basically, for your program to run, user need to enter number one, age. Number two, current year. Based on this, we understand the retirement year What is the retirement age? 60. Retirement year. What is the retirement year? 60 minus age plus current year. Correct?
Yes.
60 here is the retirement age.
Yes.
Minus the age of the user plus the current year. So if the user is 50 years old, 60 minus 50 plus current year. Current year is 2021. So 10 plus 2021 and you will get 2031. Correct?
Yes. Sir.
This is what you have to work out. You break into smaller chunks so that you can formulate. I'm sure everyone can calculate, no worries. If you are 50, this is 2021, you know that you will retire in 10 years and the year is should be 2031. But then again, of course, that is your brain. Your brain is a lot faster to calculate simple things like this as opposed to the computer. But the computer, as we mentioned, will not be able to do just that unless you tell the computer to do it for you based on this requirement. Now, how many variables can you see here? How many variables can you see here?
Is 2.
We have, the first one is the age, correct? Because
Yes.
user need to enter the age. Number 2 is the current year. User has to enter the current year. And that's it, isn't it?
Yes.
It's probably best if you also include this. Retirement year for the results. Yes, I know, Ivan. I don't doubt if you have done it. Yeah, I don't doubt if you have done it. But what we're trying to learn here is how to formulate. How to formulate. So the first variable is age. The second variable is the current year. You probably need to have the third variable for the retirement year. When you have the retirement year, it'll be easier for you to see out later on. Correct? This will be the third variable. So altogether, we have 3 variables. What is the data type for this particular variable? Age.
Integer.
Integer. Because it's a whole number, isn't it? What is the what is the data type for current year?
Integer.
Integer. What is the variable for retirement year?
Integer.
Integer. There you go. So based on this, will it be easy for you to calculate? If you fully understand the question, do you think you can code this faster?
Yes.
Yes. This is why we have to stress on formulating the first understanding the question, then find the formula. Okay, let's try to ask. Oh, hold on. There you go. Let's try to ask. Was it fun? Oh. How about if you show, Ifan? Yes. Oh, yes. You're the first one. No worries. Yeah. I was looking for your name. I couldn't find it. So, how about if you showed the class how your code looks like?
Okay, sekejap. Can you see?
Hold on. Yes. Include IOStream, include string.h. Alright. Using namespace standard, integer main. We have age, current year, retirement age, retirement year. Age equals in age. Year, current year equal in current year. Alright. Retirement age equals 60 minus age. Retirement year equal current year plus retirement age. See out retirement year. So retirement year, return now. Yes, this is correct. Only that. Now, this is correct. But, number one, you do not use any string function. So it's probably wise not to include the library. Line number 9 shouldn't be there. Because when you include a library and you do not use that, you are wasting the memory. We try to optimize the use of memory. Okay? It comes to the final part, isn't it? If you remember correctly, earlier, when we started this lecture, the very last point, best practices. So line number 9 can be excluded, can be deleted. It still works just fine. Yeah, still works just fine. Right. And in this case, yes, for this, I'm fine. Only that it's a redundant to use retirement age, apparently because you're not going to be using retirement age anyway. So you can probably do that. But then again, of course, computers nowadays are very powerful. So it doesn't matter. Even if you do something like this, it's still correct. All right? Thank you. Now, so that is done. How about if you spend the next 15 minutes on question number 4? Yeah.
Formula.
But what if? Right. Of course, I have to admit that the answer is correct, but you will not get full mark with this.
Oh, sorry.
You will not get full mark with this. Yes, you are allowed to a certain degree. You are allowed to manipulate the formula. Okay, to a certain degree, you are allowed to manipulate the formula, but not up to this point.
Okay, sorry,
Because you see, the thing is, it's not to say that you are wrong. It's not to say that you are wrong. But this can be confusing.
Yes.
Understand?
Yes, sir.
All right. So the reason why I'm telling you this is not because I cannot understand you. I can understand you. But then again, we are learning problem solving. When we are learning problem solving and you come up with something way too advanced, do you understand what will happen to the rest of the class?
Yes, sir.
They will get confused. All right?
Alright.
So it's best to go step by step. It's best to go step by step. So again, now you are going to learn. Let's have a look at some other options. Thank you.
Okay. Welcome, sir.
All right, let's have a look at some other option. Sarah. Hey, hold on. Okay. The arrow for see in is the other way around. The arrow for see in, arrow.
Oh.
Should be greater than, not less than.
Oh.
All right. Invalid operands. No more.
Oh.
Oh.
Tak perasan pula nak panah ke sana.
So you're not done yet.
Nak dah.
All right. Have you drafted anywhere? No.
On paper.
On paper. Okay, fair enough. Let's have a look at what we can formulate from here. I'll start presenting. Right, number one, we have loan. How much is the loan? 100,000. Correct? Yes?
Yes.
Yes.
Loan is 100,000. Interest?
3.5.
3.5%. And then duration?
10 years.
10 years per annum. Yeah, 3.5% per annum. And next, we want to calculate total interest. Correct? So that is 100,000 multiplied by 3.5% or per 100. Multiplied by 10 years. Correct? 100,000 multiplied by 3.5%, that gives us the interest for 1 year. But the duration is 10 years. So we multiply by the duration. Correct?
Correct.
And total borrowed is loan plus total interest, which is 135,000. Correct?
Yes.
This is loan. This is loan. This is interest. This is duration. Okay. So, oh my God, I forgot your name. What was your name earlier? Hold on. Oh, never mind. It doesn't allow you. Now, I forgot your name. Who was the first presenter earlier? Imran. Yes, Imran. Yeah. Imran, how did he did it? Basically, he just strike that out. Now, that is division. So he'll get 100,000 multiplied by 3.5 divide by 100. Sorry, divide by 10. Okay, that's the formula. Divide by 10. Of course, this is also correct, but I would prefer if you try to maintain the order of your statement. So, loan, interest, duration. Loan is 100,000 multiplied by 3.5% multiplied by 10. Keep the order like this. So 100,000 multiplied by 0.035 multiplied by 10. So by doing this, you understand that this is referring to the loan. This is referring to the interest. And this is referring to the duration. Okay, Imran?
Okay, sir.
All right. We want the numbers to reflect the variable. Essentially, this is the reason why we want to study here. I don't doubt your answer is correct. I don't doubt. In fact, it is correct. But here, in computing, we'll try to relate to that. We'll take one step at a time. And based on this, how many variables can you see? Everyone? If you want, of course, the first variable is that. Yeah? If you want also, that can be the second variable. The third variable. The fourth variable. The fifth variable. 5 variables altogether. Now, understand? Here, we have 5 variables. Of course, you can minimize it, but I would recommend you to follow the order from what we have drafted. We identify there are 5 variables. Now, let's have a look at the data type. What is the data type for loan? What is the data type for loan?
Integer.
Normally, we're dealing with money. So when we're dealing with money, we can expect to have floating numbers.
Float.
Yeah, we will expect to have that. So this is float or double. What is this? Float. Correct? This is integer because it's a whole number. We never have 10.5 years. We always go with the year. Total interest. Float. Total borrowed. Float. All right? So, based on this, can you try to answer the question? Based on this, do you have any question?
No.
what I've done earlier. Hold on. Dev C++. Loan amount, rate. In percentage. Duration years. Amount multiplied by rate. No. Rate equal rate divide by 100. Duration. Total interest, amount multiplied by rate multiplied by duration. Total amount plus interest, amount borrowed, we set precision. There you go. Let's try to run this. Loan amount is 100,000. Interest is 3.5, isn't it? Duration is 10 years. All right. Rate is converted to 0.5. Why rate is converted to 0.5? All right. Why is rate converted to 0.5? What do you reckon? All right. This is fine. Rate has been converted to 0.5. We probably need to set position somewhat differently. Here, Control C for rate. Control V, 3. Try to run again. Let's see. 100,000, 3.5, 10 years. There you go. The one underneath, we have to reset. I'm not happy. I'm not happy. Control C. Duration is fine. Here. Control V. Try again. 100,000. 3.5. Duration 10 years. Now, that looks better. And the code is here. The code is here. One, two, three, 4, and 5. Amount, rate, duration, total interest, total. And what we have here is to set the precision, the floating number. Set precision to 3, then we can get 0.035. Yeah? 0.035. Precision 2, that's where you get the that value here. Any question?
Sir,
Yes.
yang hashtag include IOM any tu why?
Input output manipulator.
Why?
Because I want to use set precision. Set precision fix here, referring to these values. Notice 0.035. Yeah? Because we're dealing with money. amount borrowed is 100,000. So of course we come to dollars and cents, isn't it? So this is the cents part. We want 2 decimal places. Rate, on the other hand, we need 3 decimal places because we want it to become 0.035 because this is 3.5%. Duration is 10 years. So in order to use set precision and fix, we must use IO manipulator.
Sir,
Yes.
do you have like a tip so that like let's say an error occur, so how do I prevent it from keep happening or happen or whatever?
You get an error during compilation. What do
Yeah,
you do? Is
sometimes.
that?
Yeah, I guess I'll show you then.
All right. All right. Hold on.
Can you see what's happening? Like, can you see this? Like,
Okay,
what's-
fair enough.
Yeah.
You get that.
Yeah.
So when you
so
compile,
when I compile it like this happened.
now, if something like this happens, yeah, if something like this happens, of course you will come across this plenty of times, no worries. Yeah?
Yeah, I actually came with this like
Not only
lot,
you.
like a lot of time.
Yes, not only you.
Yeah.
Everyone gets
A
this
lot
all
of
the time, no
time.
worries. Yeah? Everyone gets this all the time. Number one.
Right.
Number one. Ifan. Ifan.
Yes, sir.
Yes, what's wrong with this?
The error.
There you go. I'm sure you have learned something today. When you see out, the arrow is the other way. When you see in, the arrow is the other way.
Oh, right. Oh, I see. Right.
Try to
so
fix that first.
it's
Try to
supposed to
fix
be
that first.
inwards then.
Yeah, try to fix that.
All right. Right now?
There you go.
Yeah, I'm very careless sometimes. So yeah.
Try to compile. There you go. All right.
Yeah.
Now, right, of course.
Right.
Also the error. Now fix the error.
Yeah. This one.
Yes. And try compile.
Oh, wow, it worked. All right, it worked.
So it's always important. It is always important to read the error underneath. Yeah. It is always important to read the error underneath. No worries. You will come